Alright guys, this is looking at some of the quest problems for your circuits homework. So let's go ahead and look at the equations real quick that we're going to be using for this chapter. Um, First off, most importantly, Ohm's law here. I, which stands for current measured in amps, right? So whenever you see the amp symbol, you're going to write an I over it, right? Potential difference or voltage measured in volts. Whenever you see the V, it's volts, right? Or potential difference. And then, of course, divided by R, which is resistance. It's the thing that's going to resist current. It's going to resist the flow of energy. And this is always measured in ohms, which is the omega symbol. Okay? All right, so this we can rearrange and solve for each one of those things. The other basic equation you're going to need is a power equation. If you do a little bit of algebra, you end up figuring out that the power equation from back in the day, which was measured in, anybody remember what power is measured in? Like power of a light bulb? That is watts, right? So whenever you see watts, you know that that is the power symbol. You need to underline it and put a P over it. Okay, is equal to current times voltage. And remember, current is amps, and voltage is measured in volts. Okay. All right. Okay, so here we go. We got rules for series. Series circuits are things that look like this, right? They're just in like a simple loop with a battery here, and you have some resistors in series, and you have to get through each one in a series to get to finish the circuit. Whereas parallel, the circuit kind of looks more something like this. Doesn't have to look exactly like this, but it's usually going to have some parallel branches. And what that means is the electricity does not have to go through each one, right? I can go this way if I want to. I can skip that branch and go straight to the second one. Or I can skip that and go all the way to the third one, right? But I don't need to pass through each one to get there. That's why it's called a parallel resistor. And the rules are different for each, right? Okay, so if we're doing parallel circuits, the resistance is going to be 1 over the reciprocal, each fraction. You're going to make a fraction of the reciprocal, add them up, and then you have to flip the answer. So whatever you get out of this sum, you would have to flip as well at the end, right? Series resistance is really easy. You're just adding them up. Okay, and here are some very critical rules right here. So the current in series is the same through every resistor. So let's say I had 2 amps of current running through here. It would be 2 amps through this resistor, 2 amps through this one, and 2 amps through that one. Whereas in parallel, the voltage is the same. So if this is a 12-volt battery, I'd get 12 volts across this entire branch, across that branch, and 12 volts across that branch. And the current is going to be much higher. A much higher current is going to be drawn through. Okay, so let's go ahead and go through this now. Let's go ahead and do the guess method. Certain device in 120 volts. So volts is what? Voltage, right? Circuit has a current rating, so they already tell you current rating of 20 amps. So you see amps, that's current. All right, so I do that. Find the resistance. So what are we looking for? R is resistance. We don't know what that is. So what equation has R, I, and V? Let's look. All right, here we go. Ohm's law. I equals V over R. Okay, we're solving for resistance. So what's the rule? We have a top and a bottom. We can switch them. So we have R equals V over I. And we plug in what goes into V? 120. So you notice you're getting points for all this. You get 2 points for doing the knowns and the unknown, right? That's 2 points. 3 for the equation. 4 for the plug-in. 120 over 20. And then the answer comes out to 6 ohms. This is your 5th point with the unit. Make sure you got the unit on there. Okay, so we're doing that for all problems, okay? And since you don't have this, you're going to just write these out. You just write these out on your paper. That's what I'm grading. All right, here we go. Question 4. 74.9 watt. So what's a watt? Watt is power. Oh, sorry, it's nasty. It's connected to a 130 volt source, so that's voltage. What is the current? So the question, what is equals, and current is I. What equation has P, I, and V? That's the PIV power equation, right? Electrical power. So here we go. So write out the equation, PIV, so I know that you understand which one you're doing. Do I need to rearrange anything? Yes, I do. I'm solving for current. So if I'm multiplying by voltage, how do I get rid of it? Divide. All right. So P divided by V equals current. And so what goes into P? Power is 74.9 over 130. You get a predetermined answer of about 0.576, okay? All right. Now, part 5 is 2 of 2. These are connected together. So guess what? You can use all the givens from this one. This is now given, right? This is, we solved for current, so that was amps, right? This is our current. All right. So what is the resistance in the bulbs? We're looking for R. Okay, so we have, what are our givens? We have current. So the givens, current. What else do we have? We have voltage. We have power. Okay. So what equation will give us R given these variables? R, let's look back. R is not in the power equation, so we have to use Ohm's law. All right. I equals V over R. Okay, and again, what's the rule for this? Swap these guys out. R equals V over I. What are we plugging in? Our voltage was 130. And our amperage, or our current, was 0.576-ish, right? And you get an answer from that. Okay, make sure the answer is in, since it's resistance, you need to make sure it's in ohms. Okay. All right, down here, 9-volt battery is connected to 3 resistors, so let's draw this out. 9 volts, 3 resistors, 4.5 ohms, 15 ohms. We need to get used to doing these because we're going to be doing lots of problems like this in the future. Okay, calculate the equivalent resistance. So remember, equivalent just means the total, so the R total. And since we're in series, we need to make sure we use series rules, right? All right, so how do we do that for series circuits? That's incredibly easy, right? That's just add them up. So let's write the equation out. T is R1 plus R2 plus R3, right, etc., right? So it's R1, 4.5 plus 15 plus 23. And whatever that answer comes out to, you need to make sure it's in ohms, right? I'm not going to do the answer, I'm just going to move forward, okay? In the diagram below, the resistances are 3.5, 3.05, so I'm going to write that here, 3.05, and 1.96, 1.96. Since you don't have this paper, you need to draw this out, okay? So you get used to drawing the resistors. The current, so current can be represented like an arrow going through, 3.73 amps. This is the current. Find the potential difference. What's the other word for potential difference? That's voltage between points A and B, okay? So from here to here, so we're looking for the total voltage, because it's going to be the thing that runs all the way through. It's across, the difference in potential across, okay? So let's see. So this is the voltage, kind of like the total. So that means if we have a current total, let's set our givens. We have a total current of 3.73 amps. What else are we given? We're given the resistance 1 and resistance 2, which means we could figure out what the equivalent resistance, right? And we are looking for the potential difference or the voltage, right? So the equation we're going to use is going to be what? What has R, I, and V? That's Ohm's law, right? I equals V over R. But remember, since we have a total of this, we need a total for this as well. Okay, so that means here on top would go, what's our, we don't know what our voltage is, so let's multiply by what? Get this out of here, right? Okay, so we have RT times IT, so the totals here is equal to our total voltage, or our potential difference across all the resistors. All right, so what's going to get plugged into here? We're going to have to add these up, right? R1 plus R2. And then from there, we could do the current, right? And whatever that answer comes out to, make sure it's in volts. Okay? All right, over here. Now let's look at this. I want to kind of show you a little comparative thing with current, brightness, and all that good stuff. All right. Now, if we have 2 bulbs like this versus 2 bulbs like this, right? What's the difference between the two? Well, this is a series circuit, right? This is parallel. Oh, no, it's still parallel. It's a parallel circuit, right? And the rules are different, right? So let's evaluate what's going to happen. We'll assume that all of these are just 1 ohm resistors. We're going to do proportional analysis, so we're not going to really change up much, right? So what is going to be the difference in the resistance total of this one, and the resistance total of the parallel, right? So what's the rule for this guy? We're just adding them up, right? R1 plus R2. And up here, this is 1 over the total is equal 1 over to R1 plus 1 over R2, right? So let's look at what this would do, right? So this would be 1 plus 1. So what is our equivalent resistance for the series if these were all just 1 ohm resistors? So Remember, we're just doing proportional analysis, keeping everything constant, so I'm just going to use an easy number like 1. So we would get an equivalent of about 2 ohms of resistance, right? Up here, though, when we do this problem, it's purple to kind of show you. Parallel play. Okay, good. All right, so we would plug in 1 over 1, which is redundant, but oh well, 1 over 1 again. We would get 2 over 1, but this is 1 over our resistance total, so I have to, remember we said we add the sum up at the end to get this back on top. We have to flip, right? And whatever you do to one side, you do to the other. So our resistance total would be equal to 1/2. So what would happen to the resistance? The resistance, if you set them up in parallel instead, would be only half, right? So what would happen to the brightness, do you think? You'd think it would be brighter? Do you think it would be the same? Do you think it would be dimmer? Now, you're probably saying brighter, but by how much more do you think it would be bright? Well, if it's offering only half the resistance, what do you think that's going to mean for the brightness? If it's only half as hard, that means it's going to probably shine twice as much, right? So kind of keep these things in mind, all right? And remember, in terms of current, since these have the same voltage, remember the voltage drop total is equal to the voltage across the resistor 1, and it's equal to the voltage across resistor 2, because that's the rules. Them's the rules for parallel circuits. Okay? All right, I hope this was helpful.